Okay, so welcome back to this is, I guess, our eighth or ninth. I think it's week 8. So we're definitely halfway through the semester, maybe a little more than halfway. And we're definitely more than halfway through unit 3. So we're doing really good for time. There's only 6 units. So if this is just about the halfway mark, we're doing really well. All I want for us to do today, and this might take me 20 minutes, we'll see, might be a little more, I don't know. But all I want to do today is cover covalent naming. And we're going to look at 3 types of names. Okay, well, 3 types of covalent compounds. There are molecular elements. There are systematic naming rules for like more complex elements. And then there are some trivial names. Trivial names would be something like water. We don't call water dihydrogen monoxide. Following our rules, we just call it water. So we're going to talk about this today, and it shouldn't take too long. There are rules for naming hydrocarbons that are a little different than this. So a hydrocarbon would be like methane or pentane or hexane or octane. That is for students in chemistry 2. And then if I have any chemical engineering students in here in chemistry 3, you'll learn even more naming. So, I mean, naming is one of the most important parts of chemistry. If you can't name it, you can't really talk about it, right? So let's start. All I want to do today is go through all 3 of these. The first names, you can see my writing there, are for molecular elements. These are elements that exist as small molecules. So what I mean is there are more than one atom bonded together, but it's in nature, meaning it's naturally how we find these elements. So instead of like making the names complicated, we just call them their element names. These are, again, found in nature, and often in nature, nonmetals aren't found alone. They're found grouped together in small compounds that we call molecular elements. So the most common of this is one that you all, I really hope, know: oxygen. The oxygen that we're breathing in right now is O2. In nature, you don't find oxygen by itself. Not in its gaseous form. Certainly it would be combined with other chemicals. So there's things like carbon monoxide, carbon dioxide. Well, just oxygen is found in nature as O2. And there's actually 7 elements that exist in nature in pairs or groups. They would be your halogens. So I'm just going to read the names: fluorine, chlorine, bromine, and iodine. Even though there's 2 of them, F2, Cl2, Br2, we name them like we name the element. It's just fluorine, just chlorine. Hydrogen is another one, and nitrogen is another one. So fluorine, chlorine, bromine, and iodine exist as molecular elements. We call these, by the way, I should say we call these diatomic molecules. Diatomic means 2 atoms. Di means 2. So these are called diatomic. That's how they exist in nature. So nothing really to memorize here. It's just these elements, even though they're bonded to another element of the same type, we don't change the name. We just call it hydrogen, nitrogen, oxygen. There are 2 more complicated ones. You don't really have to memorize this slide, but there are 2 more common molecular elements. Phosphorus, when found in nature, is P4. Sulfur, when found in nature, is S8. And we talked about sulfur in chapter 2. It kind of takes this crown shape. You don't need to worry about those. I mean, but just know that even though there's 4 of them or 8 of them, or even back on this slide, 2 of them, we're not changing the name. It's still just sulfur or nitrogen or phosphorus. This is why you're here today. And you can see my writing from the last class. This is the big slide for today. I mentioned to my other students, in terms of naming, if you had to memorize anything in naming, I would start with ionic and then worry about the systematic covalent names. So these names that I'm going to show you in a few minutes. And what I mean by that is if you were doing, say, your final exam at the end of the year, you might have to name 5 or 6 ionic compounds on your final exam, but you'd probably only have to name 1 or 2 covalent. They're not as important in this course. So again, if you are struggling with naming, because I definitely struggled with naming when I was a kid, or not a kid, but a young student, focus on ionic, then look at covalent. So here we go, covalent compounds. Besides those molecular elements, we need to come up with some rule so that a chemical in, say, Korea or Japan versus the Middle East or in Canada, they have the same name. So what we do is we use a systematic rule, like a kind of like we use a pattern or a template for naming based on IUPAC. IUPAC is the International Union of Pure and Applied Chemistry. And they kind of help us, we use them for our periodic table, for example. So they help people all over the world have the same name for elements. So when you're naming a covalent compound, the first thing you need to know are prefixes that we use to tell us how many numbers of each atom are in that molecule. A prefix is a word that goes in front of another word. So like carbon dioxide means it's a carbon with 2 oxygens. Carbon monoxide is 1 carbon with another oxygen. These prefixes that I have written here, you have to know for your final exam. Now, let's be real. Let's talk about this course in general. Your next test, which won't be until November, obviously it will be online. I predict, judging by the way COVID is going and the way that Qatar is kind of handling it, meaning like, for example, people flying into the country still have to quarantine up until December. I don't know if you saw that in the news. What I'm saying is I have a feeling, and this is not for sure, but I have a feeling your exams might be online. Maybe, because we have like 150 students and there's no way we can get 150 students social distancing. So long story short, for now, you don't technically have to memorize these because you can use your notes, you can use the internet, you can use the YouTube videos. But if your final exam is on campus, you will have to memorize these 10 prefixes. So let me read the 10 of them. Some of them are very common sense because they follow mathematical principles. So we have mono being 1 element, di being 2. This one makes sense. Tri, like a triangle, that means 3. Tetra would be 4. Penta, that's another one that makes sense to me. A pentagon in math is a shape with 5 sides. So 5 would be penta. A hexagon would be a 6-sided shape. That's hexa. 7 is hepta. 8, my favorite, is octa, because, I'd never forget that. An octopus has 8 tentacles. An octagon in math, or like if you guys watch UFC or MMA, it's an 8-sided shape. That's octa. 9 is nana, and 10 is deca. There's not much for me to teach you here. You just have to make sure you memorize these. So let's practice this. This is not as hard as it sounds. Just a couple things on this slide. First, like ionic compounds, we change the ending of the second element to IDE. And in my class before this, a student asked the question, hold on. I gotta growl. The lion is back here. Just hold on 1 second. Okay, false alarm. I think it was a ghost maybe or something. So, sorry, I had a really good question and I didn't answer it very well this morning. A student said, why do we put IDE there? And I said, well, that's kind of just the rule. That's the rule that we follow. But then another student reminded me, it's kind of a good way to think of it. The "ide" at the end represents two different elements bonded together. So when I have sodium chloride, the "ide" represents the fact that it's a sodium and a chlorine bonded together. Carbon monoxide represents a carbon and an oxygen. So even though we're naming covalent compounds, we still change the ending to IDE. So I have an example here: dinitrogen monoxide, N2O1. We don't put the one in there. There's a couple of things that you need to know. If you put two vowels in a row, technically we erase the first one. Now, and I mentioned this to my other class, I'm not that picky. If you enter this on the computer, so if you were doing this quiz on D2L, the computer would say that you're wrong if you type this in. But that's when I would go in as your instructor and I would mark it myself and I would give you a mark. I mean, I'm not too caught up in little things like this. If you guys put two vowels together, vowels are A, E, I, O, U. I don't care. Like, I'm not a crazy person. So if you want to be perfect, and you want to be correct, we do drop the O. But if you did this on a test, this is okay for me. Again, I'm not crazy. And you'll see me do an example on this slide, kind of explaining what I mean with that, specifically in the third one. Okay, so guys, let me do 2. And then I'll do 1. And, sorry, my brain. Let me do 2, then you guys will do 2, and then we're almost done for today. So, let's do this. All right, so now I'm going to purposefully make a mistake here. All right, I'm going to make a mistake because I'm going to say, all right, I have 1 boron and 3 fluorines. So I would say, okay, I would call this mono boron. Now that's not correct. I'll fix it in a second. Trifluoride. Don't worry about the spelling of fluoride. It is weird, but there is a mistake with this. If I go back on to my previous slide, we do not use mono in front of the first element. And I kind of skipped that when I was reading that slide. That was my fault. The reason we don't use mono in front of the first element is kind of like why we don't use 1x in math. Like if you had this 1x equals 3, what your math teacher would probably want you to just say is x equals 3. I do not need the word mono on the first element. That's just one of these rules that I don't have an explanation for. It's just kind of the way it is. And again, if you did this on a test, it would hurt my chemistry soul, but I wouldn't really penalize you too much. Because if you said monoboron trifluoride, chemists all over the world would look at you like you're crazy, but they would know what you're talking about. They would know that you're dealing with 1 boron and 3 fluorines, or fluorides, whatever you want to say. So technically, we wouldn't put the mono there. All right, what about this one, P2O4O5? And let me just check the chat here because I just saw a message pop up. Oh, no. Yeah, well, you're right. Iman just wrote like 10 minutes ago. I didn't see that, but chemistry, this naming stuff is like so important because if you can't name a chemical, you can't really do much. So 2, this means di, and 5 means penta. Now I am going to make another mistake here just to show you how much I don't really care if you guys make a little mistakes. And Iman just said in the chat, you want me to know that it is 1. Again, like I wouldn't probably take off marks if you put a mono there, but most people would, and I would be very careful in other chemistry courses. People are picky sometimes. Anyways, so this one pretty much explains itself. Oops, my pen just messed up. So di means two, phosphorus. Okay. Again, if you misspell phosphorus, you forget the U, it's not a big deal. And now I'm going to make a mistake here. I'm going to say pentaoxide. Okay. Now, this to me is fine. I really think that this is okay, but IUPAC would not agree, and most chemistry people would not agree. But again, it's not a big issue. The problem here is I don't need two vowels next to each other. So what you would do, you would never drop the O off oxygen, because if you don't put the O there, I mean, it's not oxide anymore. But what you would technically do is drop the A. So you would call this pentoxide. Now, again, personally, for me, I am not that picky. I'm not crazy. So if you put the A in, you're fine, but technically it would not have an A. This would just be diphosphorus pentoxide, like carbon monoxide. We don't say carbon monoxide. And it's just rules. Chemistry's crazy, I know. All right, guys, so we're almost done for today. I'm going to mute myself for a minute and give you guys a couple of minutes to try these. You can put the names in the chat if you want. So I'll be back in about a minute or a minute and a half to check your answers for these. All right, so I'll see you in a minute. Oh, excuse me. Yeah, I'm getting some good answers in the chat there. Abdul Halim actually got them all right. Shadan and Abdul Rahman, you got the first one right. Warda got, yeah, you're fine. Everybody's fine. They are so long, you're right. Warda, I don't know what program you're in, but if you are in, if you're in chemical and you get to chemistry 3, that's not a long name. Like you'll see chemistry 3, the names are like way, way bigger than that. But anyways, that's not something we need to worry about. Beta is good. Oh yeah, so Wardham, you might have me. I tend to teach the 3rd chemistry course, hydrocarbons. They do get longer, but I'm teaching hydrocarbons now. That's chemistry 3. The students typically like it, and it's not a very hard course. So don't worry. If any of you guys are chemical students, the names do get crazier, but it's really not a hard course. I think my students really tend to like hydrocarbons. The cool thing about hydrocarbons is there's no math. You don't even have to touch a calculator. You don't even need a periodic table. Yeah, I hope it is me, Ward. I really do. I'd like to teach it for as long as I can. Inshallah, we never know what's going to happen. Okay, so guys, let's look at these answers. Everybody in the chat has gotten it perfectly correct. I'm going to do 3 more. These ones, I love these ones. And then I just have one quick slide to show you for trivial names, and that's it. So let's go through the answers here. I'll pick another color. Okay, so S is sulfur, Cl is chlorine. This would be sulfur chloride. But what I really want to do is, and I didn't really look in the chat, by the way, some of you guys might be familiar with sulfur with a pH. That's the way that the British do it. The British kind of change a few things. But I don't see it. No, I see lots of Fs, no pHs. That's good. All right. So sulfur. Oops, sorry. Hexa. Hexa means 6. Chloride. Now you'll notice there's no vowels here together, meaning like I don't have to get rid of the A. Really, the only issue you have with this vowel stuff is oxygen. Every other element starts with a consonant, which would be like A, B, C, D. So it's just oxygen you want to be careful with. All right, the last one, tetrasilicon, octa, bromide. All right, cool, that's it. Iman just mentioned something in the chat, which I was gonna get to. Yeah, so I don't know how I truly feel. Like what I mean, we're talking about like the code name, the formula versus the letter name or the written name. I don't know what I like better, but I find the next slide you guys will find a little easier. I personally, when I was a student, um, and I cannot stress with you enough how hard I found naming when I was like 18 or 19 in university doing this. I don't know why my brain couldn't connect, but I always liked this because really you just break the name down. I don't have to worry about charges. I don't need Roman numerals. All I need to do is know that nitrogen is N and oxygen is O, and there's two oxygens. I mean, the name just tells me what to write. Nitrogen dioxide, NO2. NO2. I think that's a gas they might have used a long time ago in like the dentist office, like laughing gas, I think they call it. NO2. And Abdul Rahman said that in the chat. Perfect. All right, I'm going to go a little quick through these because they are pretty straightforward. So triphosphorus pentachloride. So it would be 3 phosphoruses and 5 chlorines. Really easy doing this, I think. All right, sorry, I'm just gonna check the chat. Chat's going crazy today. Yeah. So perfect. And Iman in the chat there, just make sure you put the 3, like if you were writing this on a test or something, the number always goes after the chemical as a subscript. All right, or the last one, tetracarbon. I don't think this chemical exists. Tetracarbon decabromide, I'm not sure. I know some of the other ones are certainly real chemicals, but tetracarbon would be 4 carbons and 10 bromines. But remember, we don't write chemicals like that. We need to say, put the atom with a lowercase, sorry, not lowercase, a subscript number, and then the other atom with a subscript number. Guys, one thing, and no problem, Aman. One thing I'll mention, and this is something students mess up on every test and every final, and I've been teaching chemistry 1120 for 11 years. Every student does this. Not every student, but every class, one person will do this. There are no Roman numerals for covalent compounds. Now, covalent, remember, means non-metal plus non-metal. So if you have to name a covalently bonded chemical, meaning a non-metal with another non-metal, there are no Roman numerals. There are no ions. These chemicals are not forming ions, therefore no Roman numerals. And every year, like specifically when you do a question like this, every year somebody slips in a Roman numeral there, and there is no Roman numerals. I will take off a mark for that if you put in Roman numerals. Yeah, so in the chat, like Aman says, we don't use bracket 2. Yeah, so Roman numerals, I mean like this, right? There's no Roman numerals for molecules or covalent compounds. And if you don't know if it's a covalent compound or not, its non-metals are covalent. All right, I am done except one more slide. So we have learned about naming just some elements that exist as small molecules. We learned how to name more complicated elements like, diphosphorus pentoxide. Well, why don't we call water dihydrogen monoxide? Imagine if you guys were at a restaurant and the waiter said sparkling or still, and you said, oh, I'd like sparkling dihydrogen monoxide. He would probably look at you like you were a crazy person. Some elements are so common that we don't give them special or systematic names. We give them what's called trivial names. Trivial meaning it's just the name. I mean, water has been called water since before people knew what hydrogen and oxygen were. Well, maybe not, that's not true, but the word water is hundreds, if not thousands of years old in some way. And we don't call it dihydrogen monoxide, we just call it water. And these are called trivial names. And you have to memorize only three, these three right here. The first one you all should know. If you don't know water, well, just I don't want to be rude, but make sure you know water. Ammonia is another one you might have heard of before. Ammonia is a chemical used in cleaning agents. You can see over here on the right, specifically like floor cleaner or I know glass cleaner. If you've ever smelled glass cleaner, there's a special cleaner for cleaning glass. I don't know how much cleaning you guys do. I remember when I was younger, I didn't do much, but pretty dirty. But glass cleaners have a weird smell, and that smell is typically ammonia. And that is another chemical, a common name you need to know. Ammonia is NH3. So again, we don't call it nitrogen trihydride. We would just say ammonia. Very common weak base. The other one you might not have heard of. It's a chemical I definitely heard of when I was young. In the 80s and 90s, there was a big talk about the ozone layer. And in like the 50s, 60s, 70s, I don't really know when, but we were using chemicals all over the world that were very bad for the environment, and they were depleting or damaging the ozone layer. The ozone layer is a layer of gas in our atmosphere that kind of shields or protects the earth and us from the harmful rays of the sun. So, I mean, I'm pretty pale. I need sunscreen all the time. So when I go out for, any extended amount of time, I put on sunscreen. The ozone layer actually helps with that. It prevents some of these harmful rays from hurting us on the earth. Long story short, it's a very common and important chemical in the atmosphere, and you need to know the formula. It's O3. It has an extra oxygen. From what I know or what I understand is we have actually fixed the problem that we had with the ozone layer. You don't hear about it as much. You hear about climate change, but you don't hear about the ozone layer as much as we did when I was young. And that's because I think we stopped using those chemicals, and it's not as much of a problem anymore. So anyways, I'm done rambling. You guys need to know these three. The last thing I'll say today is, guys, you do not need to memorize anything on this slide, but there are compounds that follow different rules. And for WARDA, you're going to do this in 2420. And for anybody not in chemistry or the chemical program, you guys might hear some of these words in biology. There are other compounds that follow different rules, but it's not in this course. So you do not have to study this slide. I don't know what number it is, but don't study it. I won't ask you about methane or glucose or sucrose or anything like that. Phew, okay guys, I'm done. I'm gonna hit stop record, and if you guys have any questions, let me know in the chat. But other than that, have a wonderful day. And there is no lab after this. If some of you have a lab after this, there is no lab.